Okay, this is study guide 4, problem number 3. Let D be the relation defined on the real numbers R as follows. For all x and y in the reals, x is related to y through D if and only if x times y is greater than or equal to 0. Determine whether the relation is reflexive, symmetric, transitive, or none of these. And I'll be honest with you, this was a dangerous problem. I had to rack my brain for a few minutes on one of these parts. So the first thing that we should sort of note before we start on this problem is some properties of this. Okay, so what happens if x is positive? What does, when you, we sort of know that the danger here is when it's saying greater than or equal to 0, what we're really saying is it can't be negative, right? Well, where's the danger? Well, when one is positive and one is negative, or they're both positive or they're both negative. So let's just write out a little list of table. All right, when x is positive, what does that mean for y? Well, that means y has to be greater than or equal to 0. Okay, so for example, when x is equal to 3, y can be 7, because 3 times 7 is greater than 0. It could be 1, because 3 times 1 is 3, which is greater than 0. Or it could be 0 itself. 3 times 0 is 0, which is equal to 0. Right, so is anything greater than or equal to 0? All right. And so what happens when x is negative? Oops. Well, then y has to be less than or equal to 0. Okay? And so, for example, when x is equal to negative 2, I can't choose 1 for y, right? Because that would make it less than 0. But y can be equal to negative 2. That turns into 4, because negative 2 times negative 2 is 4. It can be equal to negative 30. Negative 2 times negative 30 is positive 60. Or it could be 0 itself. Negative 2 times 0 is greater than or equal to 0, right? 0 is greater than or equal to 0. And I'm going to do the same thing in reverse. When, just to give myself sort of a sense of what this problem looks like, I say when x is positive, that means that x is greater than or equal to 0 for the same reasons, but just in reverse this time. And when y is 0, or I'm sorry, negative, then y has to be greater than or equal to 0. Here is the important part. What happens when x is equal to 0? What can y be equal to? Any number, right? It can be positive or negative, because 0 times negative 3 is 0. And 0 times 3 is also 0. So y can be anything. And vice versa. When y is equal to 0, x can be in the reals for the same reason, but in reverse. And this will be important for us on one of these steps, okay? So let's determine if it's reflexive first. And what is reflexive? It means that the number can always be mapped to itself, right? So instead of asking about x and y, we can just say that x relates to x. Well, what does that mean? Well, let's say for when it's positive, let's say x is equal to 1. Can I map that back to 1? Well, sure, because 1 is greater than or equal to 0, which is what positive means. Okay? Or, well, kind of, right? Not including 0 itself. So I guess another way of saying, in fact, let me rewrite this because it's even more useful to say it this way. When x is greater than or equal to 0, y must be greater than or equal to 0. And when x is less than or equal to 0, y is less than or equal to 0. Well, no, that's not quite right. That's not quite right. Greater than 0, less than 0. And now what about equal to 0? Well, that means y can be anywhere in the reals. That's what I mean to write. And this is going to be the important statement, okay? But you'll see. All right, so when x is 1, I can map 1 to 1. I can map negative 1. So does negative 1 relate to negative 1? Well, -1 times -1 is a positive number, so that checks out. So it is reflexive. I can always map x back to itself. Well, how about symmetric? Well, what it's really asking is when, what symmetric really means is when I can map x to y, can I also map y to x? And so for instance, when x is equal to -1, y can be -30, right? But when I put -30 in for x, well, -1 also spits out. So I can sort of map them both ways. So it is symmetric. Again, I want you to think about that when we're drawing out these diagrams, which is like what I hope is on the exam. What we were looking for with reflexive is if there was a circle going back to itself, right? And for symmetry, what we're looking for is if there's an arrow going in one direction, could we also find an arrow going in the opposite direction? And that's what we're testing here. Now for the part that I found difficult, and I may have gotten it wrong on the test. All right? Is it transitive? And the answer is no, it's not. And here's why. It's a very special case. When I can choose 3 going to 0, right? Because let's remind ourselves what that means. It means 3, 0 is in, what is it, D? Because 3 times 0 is greater than or equal to 0. And I can go from 0 to -3. Remind yourselves what that means. That means 0, -3 is in D, because 0 times -3, which is 0, is greater than 0. But can I find a shortcut going from 3 to -3? Well, let's find out. 3 times -3, is that greater than or equal to 0? It is not. It's equal to -9. Oh, sorry. So this would be no. And how I would write it on the exam is it's transitive. It is not transitive because 3, 0 is an element of D, and 0, -3 is an element of D, but 3, -3 is not an element of D. This one's tricky. So if we have a problem like this on the test where there's, greater than or less than or something like that, especially around 0, try to do basically all the cases, going from positive to negative, 0 to negative, positive to 0, negative to 0, 0 to 0, positive to negative, negative to negative. Try all the combinations. Okay? Oh, and 0 to negative. I think that's all. Or it's close to. You get the idea. All right, that's all I got for this problem.